Alright, so we're going to be going through the binomial probability at least at most section of Unit 7, which is talking about probability. This is pretty similar to what was going on yesterday with just straight binomial probability. The only difference is now we're going to be talking about having at least a number or at most a number, which adds one extra step on. So if you recall from yesterday, students had a 5-question multiple choice quiz. They didn't study, and they were going to guess on every single question. So each question has 4 choices. What's the probability of getting an 80%? So if we recall, 80% was 4 correct. 4 choices means that the probability of getting 1 right is 1 out of 4, and there are 5 questions on the test. So our n value was 5, our r value was 4, and the probability of success, S, was 1/4. And then we just went ahead and plugged that into our calculator. So we did the binom PDF 5, comma, I'm going to change this to a decimal, 0.25, comma 4, and we hit enter, and we got our answer. So the difference now is that we're not going to be talking about specific numbers. So we're not going to be saying 5 questions. We're not going to be saying 2. We're not going to be saying 1. We're going to be saying something like this. We calculated exactly 80%. What about if they say at least 80%? So that means that now, instead of just getting the number correct, can be 4, because that will give you an 80%, or you could get a 5 now, right? Because at least 80% means 80 or above. So this would be 80%, and this would actually be 100%. So you can get either one of those, and it changes the probability just a little bit. So what we're going to do is we're going to do almost the exact same thing. We're going to calculate our probability for 80%. So we knew that, actually let me change this a little. So if we get 4 correct, or 80%, our n is going to be, we're still going to have 5 questions. Our r now is going to be 4, and s is still going to be 1/4. So we're going to go ahead and calculate. It's going to be binom PDF 5, comma 1/4, comma 4. And then what we need to do is we need to calculate the other one. We need to calculate the probability of getting 5 correct, which is actually 100%. So for this, and there's still 5 questions, but now we want to get all 5 of them right, and our probability of getting 1 right is still 1 out of 4. So it's the same thing. The only difference is instead of having 4 correct, now we have 5 correct. So again, we would plug that right into the calculator, and it would be binom PDF, and it would be 5, comma 1/4, comma 5. And now to find this, this becomes an OR problem. This is an OR problem. And if you recall, when we're doing OR problems, we're going to add in the middle. So you can try and put this whole thing into your calculator and see what this whole thing is. But what I would suggest doing is do the first one, because that's pretty straightforward. Do the second one and see what you end up with, and then add them together. So if you put this first one into the calculator, you get something like, oh, look at that, I didn't even calculate it. I didn't bring my calculator with me. Alright, so I got my calculator, I've plugged the things in, and if I change them into fractions, because the second one, this part here, actually comes up as a ridiculous decimal, but if I change it into a fraction, for this first one, I get 15 out of 1,024, and for the second one over here, I end up with 1 out of 1,024. So when I add both of those together, when I take this and add this, and put them together, I end up with 16 out of 1,024, which is going to be my final answer. I know that got close down to the bottom there. I apologize. So once again, just to kind of reiterate there, using your graphing calculator, you can do the exact same thing that we did yesterday. So you can take the binomial PDF for the first one and for the second one, and then you add them together. Okay? It's important to remember these things down at the bottom here, so that it's important to remember at least means R and all numbers above R. So if you say at least, for this problem, it was at least 4, so that's 4 or 5. If it was at least 2, it would be 2, 3, 4, or 5. And it's also important to remember that at most R means R and all numbers below. And this is including 0, with lots of exclamation points underneath it, because that is what is going to trip people up. So often I say we're doing a problem and it says, what is the probability of getting at most 3? And students will find 3, they'll find 2, they'll find 1, and that's it. But if you're getting at most 3, the reality is you could also get 0. So do not forget 0. Don't forget 0.